Today we will be working with angles using the theorems we have discovered previously. Here is a chart of all the theorems that we have learned, and we will be required to reference them in the problems below. In the first example, we are required to find the value of A and B. So first of all, to find B, I'm going to set up an equation using the sum of angles in a triangle theorem, SATT. So I know that 15 degrees plus 30 degrees plus whatever B is has to equal 180 degrees by this theorem. So my equation 1 is as such: 15 plus 30 plus B equals 180. And that is using our SATT rule. Now it's as simple as solving for B. So 15 plus 30 is 45, plus B equals 180. And now we have to bring the 45 to the other side by subtracting 45 from both sides. And then these cancel out, and B equals 135 degrees. Now that we have solved for B, we can find A using our supplementary angle theorem, SAT, that states that supplementary angles have to total 180. We know that A plus B equals 180 degrees by our supplementary angle theorem. And since we know what our B is, we can plug it in. And now we just have to isolate for A, so we subtract 135 degrees from both sides. And these cancel out, and we are left with A equals 45 degrees. Therefore, A is 45 degrees and B is 135 degrees. In our second example, we are again asked to find the angle values for angles L, M, and N. I want to start off by using our sum of angles in a triangle theorem to solve for angle L. So we know that L plus 30 degrees plus 70 degrees has to equal 180 degrees, and that is by our SATT. Then we know that L plus 100 equals 180 degrees, and now we have to isolate for L, so we'll subtract 100 from both sides. And these cancel out, and we're left with L is equal to 80 degrees. To find our value of angle N, we are going to use our corresponding angle theorem, or the F pattern, which is seen right here using the parallel lines. And because we already know our value of L, we know that by this theorem, M is the exact same. So by this theorem, we know that M equals L because of our corresponding angle theorem. So that means M equals 80 degrees. And finally, to find our angle N, we have another corresponding angle theorem application. Right here, as we can see, N is also equal to 70 degrees by this rule. So we know that N equals 70 degrees by the corresponding angle theorem. Therefore, L equals 80 degrees, M equals 80 degrees, and N equals 70 degrees. Our final triangle, we will be asked to solve for X and Y. So first of all, I'm going to solve for X using the sum of angles in a triangle theorem, because I know that this angle plus this angle plus this angle should all equal 180 degrees. So 3x plus 15 plus 5x plus 30 plus 6x plus 5 are all 180 degrees from our SATT. Now we need to rearrange and combine like terms. So we'll put all our x's together and all our numbers together. And we're left with 14x plus 40 are equal to 180 degrees. Now we want to bring the 40 to the other side, so we'll subtract 40 from both sides. And these will cancel out, and we're left with 14x equals 140. And then we'll simply get rid of the 14 by dividing 14 by both sides. and we're left with x equals 10 degrees. And to figure out our value of y, we're going to use the supplementary angle theorem because we know that the total of these two angles has to equal 180 degrees. So y plus 3x plus 15 equals 180. We now know our value of x, so we'll plug that in. Is 10. And now we'll go through the math. So 30 plus 15 equals 180. Y plus 45 equals 180. And we'll subtract 45 from both sides to get rid of the 45. And these will cancel out, and we are left with y equals 135. Now that we have solved for our values of y and x, we can solve for the exact values of each of these angles. And I have laid it all out down here for you. As you can see, I've plugged the value of x and solved for each of the angles.